ATRA webinar.
The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome to another ATRA webinar. My name is Mike Souza. I am the ATRA Senior Research Technician. Today's webinar we're going to be talking about the 65, 66, and 68 RFE comparison. Hope everyone's got their volume up so they can hear me okay. And some of you guys that are listening to me on the phone, that's fine also. The reason that we put this particular webinar together is lately we've been receiving a lot of questions as to these two new designations that we're not used to seeing, the 65-66 RFE. So we did a little bit of research at ATRA and we kind of came up with this information for you guys, so let's begin. First thing I want to do is I want to thank Seal Aftermarket Products. They've sponsored this webinar and several of the others. They've made them available to everyone, not just to ATRA members, so everyone can log in and watch this webinar for free. So we want to especially thank them for that. If you have any questions or comments, please contact Lance Wiggins at ATRA. That's his website address right there, lwiggins@atra.com. If you have any questions during the webinar, feel free to text them in the questions tab that you see there, and I will try to answer them as best that I can. Okay, the 65, 66, and 68 RFE are all rear-wheel drive, fully electronic. It's been the same way since the 45 RFE came out back in 1998. The 45 RFE was first used in the 99 and later Jeep vehicles. Chrysler always has a habit of testing out their new transmissions in the Jeep models before they try them out in Dodge vehicles. In 2001, the 545 RFE arrived. It was the base that actually created the other 6-speed that we're going to talk about today. In 2006, the 68 RFE came out. And again, that was derived from the 45 RFE, but they put that one behind the 6.7 Cummins diesels. Then in 2012 is when all the questions started, because in 2012 the 65 RFE arrived, but it was only used on V8 Ram vehicles, 1500s, the Durango and Grand Cherokees with the V8 engine. Also in 2012 the 66 RFE arrived. And the 66 RFE actually uses all 6 forward gears. Now, what I want to point out here is you'll notice the 45, 545, and the 65 RFE are all basically in the same case. The 66 RFE internally is some differences. The cases look almost the same. Obviously, the 68 RFE is much larger, and it's easy to distinguish which one you're working on there. The ID tag that you're going to find on the side of the case, just below the case connector right there, and is going to be the way you're going to identify which one you're working on, because you may get confused between the 65 and the 66. Now, if the label is missing, damaged, came off in the wash tank, whatever, the actual part number is still stamped into the case just above the pan right there on the pan rail. So you don't have to worry about the tag becoming lost or damaged. Now, basically, in 2012, the 545 RFE was just recalibrated. It was they introduced it as the 65 RFE. So for the rest of the webinar, you may hear me refer to the 65 RFE, but it's basically the same transmission as the earlier 5-speed. They brought that out in the V8 models. The only thing that they really did, there was a couple of things, but the most important thing was they improved the torque converter. Physically, it's the same transmission. Now, the key difference between the two is when you're in the electric range selector mode, or some guys refer to as sport mode or Tiptronic, the 65 RFE rather will actually use all 6 gears. So in the electric range select mode, you can shift this to all 6 gears. But in the regular drive mode, it works just like a 545 RFE. Now, the shifter that they're using is basically the same type shifter they were using on the NAG 1s that came out in the 2005 Jeep vehicles. The shifter assembly itself is a common base, but there are some differences because of strategy, so the components inside are going to be different. So it's not like we can just swap them back and forth. In the normal drive position, like I said, the 65 works just like the 545, never used in second and third gears in succession. Now when we get to the V8 trucks, the 66 RFE is a clone of some of the 68 RFE internal components, such as the gear sets and ratios, but it's kind of packaged in a 545 RFE case. The 68 RFE has the same torque capacity as an Asian AS68RC that you'll find in the Ram heavy-duty vehicles. The AS68RC case provides the capability of putting on a PTO where the 68 RFE doesn't. One of the common things between the two, though, is the AS68RC has the same 6-gear ratio. One of the things that the AS68RC has that the 68 RFE doesn't have is it has a stepper first gear. It gives you more power on takeoff with a heavy load. The chart that I'm showing you here is going to show you the difference between ratios. The 545 and 65 RFE, basically the same thing, same ratios. The AS68RC, you'll notice in 6 gear, it's the same, just about the same as a 66 or 68 RFE. Now on the 545 and the 65 RFE, second prime is normally used in the third gear position, and you'll see that on the next chart that I'm going to show you. Now, when we were talking earlier about the 66 RFE deriving from components of the 545 and some from the 68, we're going to kind of go over that. Now, the components that derive from the 545 are normally found in the front end of the transmission. Obviously, that includes the converter, the pump, the whole input drum section with the underdrive, overdrive, and reverse clutches in it. The valve body was also derived from the 545 RFE. Most of the components found further back in the case are from a 68 RFE. That also includes not just the planet gears, but it includes the 2C clutch, the low reverse clutch, and so forth. Here's a diagram that kind of gives you a picture of what I was talking about. Everything that you see here on the left in blue is carried over from the 545. Everything that you see in green is carried over from the 68 RFE. What's common between the both is what you see in red, the actual input clutch drum and that sort of stuff. One of the things that changed, and we learned this when the 68 RFE came out, and obviously the 66 operates the same way. That's a major difference between the two, between that and the 545. Being that the gear train is identical to a 68 RFE, you can see that the 4C clutch actually holds the sun gear, it's part of the sun gear. And the 545 holds the ring gear. So that's a major difference in components right there. Here I'm showing you a picture of the sun gear, which the 4C, it's all made as part of one, it's all in one. And as you can see, the sun gear is separate from the planet on the 545. So obviously when the sun gear is being held by the 4C clutch, it causes the ring gear to be driven. And the same thing when the 4C clutch on a 545 holds the ring gear, the planet is driven by the sun gear. This is a great little chart we can use here that shows what's applied as far as clutches, what clutches are holding, which members of the planetary system are being driven, and which ones are being held. So if you have a noise problem, and you guys know as well as I do, chasing the noise in the shop sometimes can be really tough. So you can use a chart like this to see when a planet is being held and when it's turning. So if a noise actually goes away in a particular gear, you'll be able to try to pinpoint exactly what component is giving you that problem. Here's the component apply chart for both the 545 and 65 RFE and versus the 68 and 66. Now, as you can see here, you got first, second gear, and we have a second prime, third, fourth, and fifth. So this basically has 6 gears to it. although they only use 5 out of the 6. The second prime is used for a forced kickdown. If you're going highway speeds and to prevent the engine from over-revving during kickdown, they'll actually kick it down to second prime, which as you can see is a little bit higher ratio than the normal second gear that you would get in a normal upshift. And over here on the right, we can see that the 66 and 68 RFE has all 6 gears being used. One thing I want to mention, in 2010, all RFE transmissions are now using only the four-wheel drive filter. So you have a deeper pan, and as you can see, the filter has a tall stack on it. They still also use the spin-on filter. Another change in 2010 for the RFE transmissions, the TCM and PCM are now actually housed into one single module. So we no longer have a separate TCM. We're using one module for everything. We've kind of seen this a little bit earlier on too with the 41 TEs, the 62Es, the TEs. They also went to one new module, and you'll see 4 connectors on those. Most of the time on those modules, it's usually the green face connector that controls most of the transmission inputs and outputs. Now, another way to tell the difference of what you're working on if you get a 65 or a 66 in your shop, and again, remember the 65 is identical to a 545, the way to determine quickly which one you're working on is you'll notice the 66 RFE that the underdrive and overdrive club shafts are different. The 68 and the 66, you'll see one single spline, like we're showing you right here on the left. And then the 65 and the 545, you'll notice 2 splines here. So that's a quick way to determine which one you actually have. Now that goes without saying, if someone is has been into the transmission before you and obviously started mixing up parts, which can be a nightmare on just about any transmission that you work on. Okay, all RFE applications, the underdrive, overdrive, and reverse clutch assembly snap rings may look the same. So when you start robbing parts from cores, or you're installing used units, or you take another unit and you're swapping over to one that somebody's been into before, be real careful with these snap rings. They're not interchangeable. They can cause you a lot of headaches, so just make sure you're using the right parts for the right transmission. When it comes to clutch clearances, there are some similarities and differences between the 3 transmissions. The underdrive clutch clearance, according to factory specs, is not adjustable. Of course, you guys know that out in the field, in the real world, we always find different ways to change clutch clearances to come up to the specs that we need. Now, the overdrive clutch clearance is a little different. It's adjustable on the 68 by obviously the way of by a selective pressure plate, but on the 545 and the 66 RFE, it's not adjustable. So you can't adjust it on that. Again, in the field, I'm sure guys out there will find ways to work around that. Now here we're showing you the reverse clutch clearance and a way to check it. The reverse clutch clearance is obviously adjustable. There's the selectable snap ring. What I'm showing here is we're air checking the clutch pack. So we can see the dial indicator change as we apply and release the clutch. One of the important things I want to mention here, if you're using full shop air, it's not a good idea to air check that way. You should dial it down to at least 30 psi. I've seen several pistons, especially molded pistons, with extra pressure, they overcome a leak and actually have the piston seal. I know the old rule used to be the more air we give it, the more likely we'll pick up a leak. But you would really be amazed on how many times a molded piston will air check fine, put it in the vehicle, and it doesn't work. Now, there are 2 tapered snap rings on the input clutch assembly. These are directional. Most snap rings in any transmission, the tapered side usually faces up, almost like the general rule of thumb on ID marks. It's always going to face up where you can see it as you're assembling something. Same thing goes with these tapered snap rings. You'll want to see the tapered side facing up. Just as with the input clutch assembly, there are some similarities, like I said before, and differences between the 4C and the 2C clutches on all three of the RFE transmissions. The 4C clutch retainers are the same for all three, the same number of clutch discs, and the same, obviously the same clearances and measurements are all going to be the same as well. All of these transmissions, on all of these, be real careful with these molded pistons, especially the 4C piston. We seem to be getting a lot of calls on the tech line lately that guys are assembling the piston and they're having a problem with the 4C piston and cut the outer seal. These pistons are not cheap. And as you guys know, when you have to buy them, sometimes you have to buy the whole set. So if you damage one, you may have to buy a complete set of them. Now, one of the things you could do, and a lot of guys are doing out there, is to wrap something around the piston and freeze it for 20 minutes or so, and it'll drop right in there. There's aftermarket products like Seal Easy cones that can do the same thing. They come with a spray that'll freeze it up if you want to try to do it a little bit quicker, or you can use the cones and put the pistons in the freezer and hold the lip seals in tight so that you can assemble it real easy. Okay, like I said before, the 4C clutch clearances on all of these transmissions is adjustable. It has a selective snap ring. The 2C clutch on the 66 and the 68 has one more disc than you'll find on the 545 or 65 RFE. The piston on the 66 and 68 is much shorter. It's to make more clearance for the extra clutch. On all three, when assembling the 2C clutch assembly into the case, make sure you put the reaction plate in first. Kind of reminds me back when the E4OD first came out, we had a little bit of a mix-up sometimes on the bench with installing the intermediate clutch retainer plate last instead of putting it down in the case first. It's kind of a force of habit from always loading clutches into a drum where the steels go first and the reaction plates last. So you want to make sure that you assemble that correctly. Now, when you want to measure the clutch clearance on a 2C clutch, you temporarily install the 2C clutch and 4C bulkhead retainer. You're going to put that down in the case with all the other parts left out. Now, again, according to the factory, that clutch assembly is not adjustable. So obviously, if it's out of spec, when you go to check the clearance, you will have to change the entire clutch assembly. On final assembly, when we do put the 4C retainer down inside the case, make sure that the feed holes are facing up towards the valve body, so that the open ends are up. Now here's a great example of what I was talking about before. Now here's your tapered snap ring. See how the case is actually cut straight on this side and actually tapered a little bit here. Obviously, trying to force this snap ring in upside down, it may go in, but it's not going to hold in place, and it's possibly pop out once the vehicle is in use. So be real careful with these snap rings. The other thing is the opening of this snap ring, you'll notice, is also aligned with the opening of the case. So try to keep these snap rings the same way. Another area to find differences in components, especially in the planetary gear sets, and we're showing you here that the 4C hub again, this is the 4C hub with the sun gear attached to it, and the 65 and 545, obviously, the 4C hub is attached to the ring gear, and you can actually see the weld that goes along to it, so it's a one-piece item. The reaction ring gear is welded on the reverse carrier, as you can see on the 66 and 68. But over here we have a planet that's just the planetary by itself without the ring gear on the 545. The input carrier assemblies includes the reaction ring gear and the input ring gear on the 66 and the 68. Obviously, they're using the same gear train, so nothing changes there. There's another look at the input carrier assembly. We put the, as we showed you on the previous slide, we take the input ring gear here on the right, place it down over the planet assembly, and it's all completed into one. And as you can see, the 65 and the 545 are over there on the right. Now, because of the difference in the design, the 66 and 68 does not use the number 7 thrust bearing. And another note that I want to make is the number 11 bearing is now trapped inside the input and reverse planet assembly. As you can see, the planet gears extend out over the bearing, so the bearing can't fall out of that area. Now, if I was going to check this bearing to make sure that it's good, I would have to take a sun gear and kind of press and rotate down on top of the bearing to see if I could feel any roughness, in case of, you happen any kind of whining noises or anything like that. This diagram shows where all the thrust bearings go. Not only does it show the location of the bearings, it also shows the direction that the bearing has to face. Now, it's kind of important because as you can see this raised lip, we're going to explain a little bit further as to why that's set up that way. But just notice that on this unit, the number 7 is missing. And I want to point out what I was talking about on the bearing. Notice this area of the bearing is flat, and the rolled edge is on the inside. And notice the extension on the sun gear. That's going to pilot that bearing and keep it in place. One of the other reasons that you always want to put bearings back the way that they were designed to go is for lube issues. On some transmissions, especially Honda's is one of them that I can think of, the way that the bearing is set down inside the component is for lube to get into the bearing better. So obviously, if it's designed to have lube oil coming in from the other side and we flip this over, we're kind of restricting it. So we want to make sure that we put the bearings in the way that they were designed to go in. Okay, you'll notice that on the 66 and 68, the low reverse clutches changed to a 14 single-sided clutch disc, and there's a larger inside diameter. The 65 and the 545 RFE usually use 12 double-sided clutches. Someone asked me at the last webinar, can I take the single-sided and put them into the earlier unit? If you could make that work and the end play comes out correct, I would say go ahead and try it, but it's not something that I know of anyone doing. I don't know if any problems have been caused by it. And obviously, out in the field, we want to try different things with that to try to improve the transmission. But me personally, I would probably use the correct clutches for the correct unit. Several reasons. The clutches are designed to the strategy of the software in the vehicle to control the clutch apply. So I would probably keep the original clutches or the original type clutch for that type unit. One of the things you want to be careful of is there's a slight raised area here that you can see on the pressure plate. Make sure that faces up. We wouldn't want an uneven area to be facing down on top of the clutch. Now, the clearance is adjustable. There's a selective snap ring that you can adjust the clutches on the low reverse. Another big change from the 66 and 68 from the 545 is they use a Sprag type clutch, overrunning clutch, where the 65 and the 545 RFE use a spring and roller. Let's talk a little bit about end plate checks. We're talking about here the input shaft end plate. Obviously, we're showing you some OE tools, and I give you the part numbers or the adapter numbers for these tools. whatever way you're using to check input shaft clearance on the transmissions that you work on in your shop will work just fine. One of the things I do want to mention, when you're doing an end plate check, you'll notice that when you pull on the input shaft to check the clearance, you'll notice like it kind of stops twice. You'll feel like one little click and then you'll feel the next one. The first click that you're feeling is really the input shaft moving on the input clutch hub. You kind of want to subtract that measurement from the total measurement. The movement of the second stop is your actual input shaft end play. So if you wanted to pull the first, come up to the first stop, reset the dial indicator, and then that second one would be your actual input shaft clearance. Now the clearance can be adjusted. Obviously you can see here that the selectable thrust plate, and it goes behind the input clutch right there on the number 5 bearing. The output shaft end play, being that the 66 and the 68 share the same rear case components, the adjustment and end plate checks are going to be the same. So there's no difference there. And we're showing you the OE tools here if you wanted to actually use them, or use whatever you're using in your shop now. Now, output shaft end plate, there's a thrust plate that goes down on the back of the reaction sun gear. Now, there's some notches cut out actually in the plate, and you can see them right here. These notches have to align with some lugs on the hub. So make sure we align that, because if we get that out of place, we could try, it could actually bind the unit up, or we're going to throw our end plate check off dramatically. So be careful when you're putting that thrust plate down there on top of the hub. Okay, that about ends the portion of the 65, 66, and 68 RFE transmission. I want to just mention that we still have plenty of time for anybody that wants to register for the expo this year. We're having it at the Rio. It's an awesome hotel. It's always a great time to go to Vegas, and any time it's a great time to go to Vegas, but Halloween, there's nothing beats Halloween in Vegas. Not only that, the fact that you're going to, there are going to be some really great speakers there. There's going to be some great information to get the handout material for that and have that in your shop. So you still have about 85 days, 14 hours, and 26 minutes. Again, I want to thank Seal Aftermarket Products for sponsoring the webinars for us and making them available to everyone out there. We even have one gentleman down in Brazil that's logged in. If you guys have any questions and you're using the phone headset to listen in on the webinar, you'll see a little hand icon by your name. You can click on that, and I'll put you on speaker so I can hear you. Or if any of you other guys want to ask a question now, that's fine. I'll leave the webinar open for a few more minutes in case anybody wants to text in any questions. And I just want to thank all you guys for attending, and I appreciate you listening in, and hope I see you guys in Expo and at the next webinar. Thank you.